If we have a system of linear equations that has at least one solution, we call that consistent. And if we have a linear equations without a solution, we call it inconsistent. Now, these are all going to be linear equations, so two lines. So it could be that the lines do not intersect, that we have no solution. So that might look like this. Okay, and what that means is our graphs have the same slope, but the y-intercepts are different. Okay. Now, it could be that we do have a solution. Okay, so we have these two lines and they intersect somewhere. And that means that their slopes are going to be different. So anytime there are different slopes, eventually they are going to intersect. Now, we could have one other situation where we have infinitely many solutions. Now, this happens when it's the same line. The two lines happen to be directly on top of each other, so any point on this line is a solution. So in this case, they have the same slopes and the same y-intercepts. Okay, so there's a lot the same about them. Now, I want to be clear about this one. We're going to see this example in a little bit. This has infinitely many solutions, but it doesn't mean that everything in the world is a solution. There's a difference. There is an infinite number of points on this line, but there's also an infinite number of points not on this line. So we're going to need to be really specific about what infinitely many points are on the line. So we'll get to that in a minute. Not yet. All right, so in number 5, we want to sketch this graph and describe the number of solutions and state whether it's consistent or inconsistent. We're going to do this one by hand. Of course, you can do it on Desmos as well. So it's probably easiest to solve this for y, so we can graph it nicely. So I'm going to add 2x to both sides and then divide everything by 3. So I get y equals 2/3 x plus 2. So we'll start at 2, count our slope up 2/3. We'll go the other way. And that's what we end up with. We're going to take this other one and also solve it for y. So I'm going to subtract 4x from both sides and divide everything by -6. Be positive 2/3 plus 3/2. So this starts at 1.5 and then goes up 2/3. And then it'll go down 2/3. And you can see right away from this, before we even graphed it, these have the same slope, but different y-intercepts. So these are parallel lines. There's no solution to this. And the vocabulary word we use for it is inconsistent. All right, let's check out one more problem. We want to solve this system of linear equations. This time we're just going to do it algebraically. We're not going to graph these. I think I'm going to eliminate x's. So I'm going to multiply this by 2. That gives me 12x minus 10y equals 6. And the bottom equation is negative 12x plus 10y equals 5. Now when I add these, the x's eliminate, the y's eliminate, so I get 0 equals 11. Now, clearly, 0 does not equal 11. That is not a true statement, so this means there is no solution. This is an inconsistent system of equations. So if you get some sort of nonsense like 0 equals 11, that tells you there is no solution.